Welcome to week 7, day 31 of the fall 2024 Programming Fundamentals with C Sharp. I'm Jim Kaufman with Rankin Technical College. Today we're going to be covering the Chapter 12 hands-on test. Just going to do a quick walkthrough of that. I was going to do a walkthrough of the Chapter 14 and 15 labs, but there's some concepts in there that I think I'd like to go into a little more in depth. So I think I'm just going to go ahead and create a separate video on that one. And I should have that done before the end of the day today. So I'll send that out as well. And then I'm going to go ahead and review that food order lab just a little bit. And basically kind of just go over some concepts because, I know that a lot of the creating classes and the objects, it's all very new and can be very confusing. So I'm just going to go over a few things on that. And I just wanted to kind of go through the enums a little bit because I know that is also an area of confusion a little bit on how to access them. And I'm going to go ahead and do a lecture. I'm going to lecture over chapter 15. I'm not going to go cover like the whole chapter or anything. I'm just going to cover some basic principles and we'll expand on that from there. I don't want to. There's a lot in all these chapters. I don't want to cause a lot of confusion, and there's really only a few things you really need to know for the chapter 14 and 15 labs with respect to it's about interfaces and generics. There's only a couple things you really need to know. So I'm not going to spend a lot of time going through that. So first, we'll go ahead and get started here, and we're going to walk through the Chapter 12 hands-on test. So the first exercise is basically a way to crack hash passwords. Okay, it's the user, and it's basically this is how hackers can do this kind of thing, and they actually create what's called a rainbow table for common passwords. So that's why they always tell you never use like the word password as your password, because if the thing you're logging into, the site or the functionality you're logging into it uses the MD5 passwords to create hashes for the passwords, then basically you can actually have a list of all the common passwords and their hash. So if this hash is in a database somewhere and it's in your list, you'll know what the password is. And I'll kind of show you that here real quick. So let's go to a password generator. So there's that link right there on there, right here down here, and that goes to this hash generator. So you can create your own hashes from passwords. So a lot of people do have their password be a password, right? And so it creates this hash. Well, it's always going to create this hash from this set of text, right? So this word password is always going to create this hash. So if you were searching and if you had access to a database and you had all the hashes and that hash is in your table, you know that their password is actually password, right? So the purpose of this is to create a table, right, of a password and then get the MD. You can use these if you want, or you can go ahead and create your own. So you're basically creating a list of passwords and hashes. And just to go through this a little bit, since we've got a UML diagram. So this is basically saying, just as a review, if it starts out with a dash, right? If it starts out with a dash, it's private. So these are the private instance variables. One underscore raw, the other underscore hash. They're both of type string. Then here, your methods, right? So if you know that this method is the same name as your class, you know this is a constructor. So this is your no parameter constructor, and this is your constructor with parameters, which is basically the two strings here, the two instance variables, raw and hash. Right? And then down here, this is basically just telling you, okay, well, yeah. And right here, you've got your properties. So since obviously these are private instance variables, so when you're outside of that password class, the only way to access this data here, the stored in raw and hash, is through your properties, right? So your properties are raw and hash here, and it's showing you just need to create gets, right? You're not doing any sets, right? So, and kind of another piece of information, just kind of in review, is obviously when you can see that this is just gets, well, we're not setting the data this way, right? Sometimes these are gets and sets, then that's one way to set the data. So here it kind of actually shows you that this password, this constructor here is how you're setting the data, right? So you're calling this constructor to pass in your raw password and your hash, right? This is kind of this password with no arguments, the no parameters. This is kind of redundant. You're not actually using it in this case because in most cases because you're not going to be able to do like you could do this to do your gets, but you're not going to be able to set anything using that, right? You're going to use this constructor to set your data. And then here we just got a password cracker, and this is just telling you this is a method in your form, right? So this is the only class you're going to have is password, and this is just telling you there's a method in the form. It's just telling you to create this method. Okay, this shouldn't be too bad at all. Compared if were able to get through most of the labs, this should not be a problem. And then here you've got basically another situation. You got a list of three different things here. You have a computer name, an IP address, and services. And so once again, you've got a computer object. You have a computer class, and you have three instance variables: name, IP address, and services. And then here is, obviously, you can always tell, and then a plus means, the dash means private, right? The plus means public. So here's your public constructor, and you're passing in your name, your IP address, and your services. And then here you've got your properties, right? Which set the values of your instance variables, and you have a name, IP address, and services. And these are just gets as well. And then here you've got network scanner. This is just your form. So you've got two methods: scan IP address and show computer. And this is just saying the services field and the property of the computer class can optionally be made string. So the services here can be optionally made string. And let me see if there's anything else on here that looks to be difficult in any way. I don't think so. I don't think this looks too bad. Maybe easy for me to say. But if use your other labs as a guide, and just don't get confused by this down here, right? It's telling you to create your form as a network scanner form, right? And then this is just your methods inside that form, right? And basically up here it's the same thing. Call your form, right? So you can change the name of your form. A lot of times people call it lab 1, lab 2, or whatever. Change the name of your form to password cracker, right? And then here's your method, crack password. So that's that. And then, always just remember to come down and look at the rubric. And so what you're going to be graded on. So make sure you follow these best. I know, I haven't been, people have been doing a pretty good job of, being consistent with their conventions. And I think that that's more important than anything is, consistently call your things uppercase or lowercase or that, as long, being consistent's important. Sometimes being consistent, being, there's not necessarily a right way. Naming conventions is usually a like suggested type thing, but being consistent is really good because when people come and, you always have people when you're working a job, you'll have other developers that are coming behind you and, when you're following a consistent pattern, it's best. And usually companies are always going to have their conventions, their naming standards as well. Okay. Usually they follow the industry standards, but sometimes that isn't always the case. But, make sure you read the rubric very carefully so you get as many points as possible. Okay. So I don't think that's too bad. Please let me know if you have any questions. And, you'll have 2 days to do that. So you'll have until today's Tuesday. You'll have Thursday till 7 in the morning. So the next thing I wanted to do is, so like I said, I'm going to go ahead and I'm not going to walk through these 14, 15 labs. I'm just going to create a separate video on that because I want to go through a few concepts on that as well. So now I'm going to go ahead and go through this food order a little bit. And please let me know if you have any questions about this as we're going along. So, this is quite a big one, obviously. And how to approach this. Let's first kind of go through this a little more, this UML. And I'm not going to go through the whole thing front and backwards, but, kind of the big things like we've already discussed before. When you have a dash before your name, these are instance variables, and since it's a dash, these are private. If you have a plus, these are public. So to access your name, right? Name, Sunday, and soda, right? To access your name, Sunday, and soda, you use these properties to update these. Update or get these, right? In this case, you're just doing gets, right? If this had a set, you could be setting or getting. But in this case, and it's okay if you had both a get and set, but, basically the purpose is just to have it's stating just to get. So this is how you're basically getting these variables after they've already been populated, right? And for the way these are populated, these instance variables, is by using your constructor, right? So here you've got your constructor, and you know that your constructor is always the same name. In this case, let's make it just a little bit bigger. The same name as your class. So here's your class order, right? And so when you're from your form or from another class possibly, you're going to create a new order object. And you're going to create that new order object by passing in a name of the order, okay, which is a string, a name of the order, and then you have two Booleans here, right? And it's so basically on your user interface, you have those check boxes. So if you have the Sunday checkbox checked, this is going to be true, right? If you have the has soda, right, you're going to pass true for this one, right? So if you check both of them, you're going to pass in your order name, and then you're going to pass in true and true, right? So let's go look at this here a little more. So I think a good way to approach this, if you're starting from scratch, is now that you know what you need to create an object, you need the name of the order. You need to know if it's a Sunday or a soda. So when you're writing your code, you click this add item to order, right? When you click this button, you need to, first thing you got to figure out is, from my perspective, do I have all the information to create that order object, right? So I need to make sure that I have a name for the order. I have at least either a sundae or a soda selected, right? If I don't have a sundae or soda selected, it's not really going to be a valid order, right? Because in this case, you only have two options, right? You can have either a sundae, a soda, or both, right? So the first thing I would do is I would come in here and I would, in our code, and we're going to look at a little bit of the code. I'm not going to show you the whole completed thing, but I'm just going to show you some sections. So the first thing you want to do is you want to make sure you want to check to make sure you've got a name in this, right? You need to make sure you've got a name in that, whatever you call this text box. You want to make sure you've got a name in this, okay? So that's one thing. And then you want to make sure that you have either a sundae or a soda or both, right? And then also the other thing is you want to make sure when they chose toppings, if they chose 3 toppings, that's not allowed, right? So you might as well validate all of this. You might as well check all of this before you even create the order object. Because if not, you're going to have to come back to the screen and basically display this error message, right? And like I think I said when we went through this last week, I would just have these on your screen as labels, right? Name required, and then just change the visibility to false for each of these. And you can change the visibility to false, and then if nothing's in the order field, then you would go ahead and change the visibility of this label to true, so it would show this. Well, and then you'd return it, you'd have to return it back to the screen here, right? And also the same as here. I would make each of these as labels, and then if it doesn't pass your validation, your checks, then you would go ahead and return it back to the screen and display this label or this label, okay? And this is a rich text box, okay? And you can look into that. I think that that's the best thing to use for this. That way you can kind of keep on adding additional data, additional stuff to this, okay? It's a good one to use in this certain circumstance. What else do I want to show on this? Okay, so let's look at a little bit of code on this. So I'm not using Visual Studio here. I'm just using Notepad++. One thing I did do, I already created these some of these classes from the UML, and I did update this. It'll still work. What's out there? I updated this one just to kind of more of a long form thing, just to make this a little more understanding. Okay, it's easier to understand kind of this long form for these properties, right? Before it just had name, set, get, right, for each of these. And it didn't even have these instance variables. It will work how it was, but this is just a kind of more of and actually this follows more of the UML diagram. But, this is, a more traditional, a little bit more code, but I think, easier to understand here, right? So here's your private instance variables, right? And so you have a string, which is the name. You have a sundae, which is type sundae, right? You have a soda, which is type soda. And so obviously, you created, we have code for all that. You've created all these as separate classes for this lab, I'm assuming. So then here, so for the name, to update the name, you provide a public method to update the name. And these are called properties, right? These are called your instance variables, and these are your properties that you use to update. These are made public so that you can then you can update them. Outside of this order class, these are not accessible. The only way these are accessible is through using these properties. Okay, so in this case, you have a property called name, and you have another property called Sunday, and another one called soda. Now, this is kind of a bad example, actually, because in a way, because this is this, as this is your access modifier, right? This is your type, and this is your name, right? The name of your field, right? And usually name's always a bad one to use sometimes too, because you call them names, right? What's your name of your field? But but this is your access modifier. This is your type. This is the name of your field. Or, well, this is the name of your property, right? And here, basically, this can kind of look a little confusing here. Well, basically, this is your access modifier. This is your type, and this is your name of your property, right? This isn't like, this isn't, I can see how this can be very confusing. This is your type object, right? This is the type. This refers to that class. This is just a name that you're giving it. So I that can be a little confusing there. I can see that. Okay. And so the same for soda. So basically here for a get, so there's different ways to do these variables and these properties, and probably important just to learn what works for you and be consistent, because there's some shortcuts. Be easier, long time ago it was actually easier because there's kind of really just one way to do it, and that was it. And then they come, okay, well, let's create this other shorter version, you can do it different ways. Kind of thing causes, a lot of confusion, especially for, people just starting out, right? But so to update this name, to update this underscore name variable, right? You call name, right? And what you would be doing is you assign a value to the name. Okay, we're going to look down here. Let's just easier probably just go this route. So here you've got your constructor, right? This is going to create an order object, right? And you're passing in name, and then your two booleans, has Sunday, has soda, right? And so then you're saying that the name that you pass in, okay, the name that you pass in here, set this to name, okay? So when you do this name equals name, what it will do, the code will come up here and it'll say name, and it says you're assigning a variable, so that means this is a set, right? You're assigning name to this, whatever this value is in here in the lowercase name, right? So it's going to come up here and say, okay, you're setting a variable, so you're calling this, okay? And here's your instance variable is underscore name, okay? So it's going to set this to value. Now, this isn't something you come up with on your own. This isn't developer created. This is a built-in keyword that's used to set a value. So it's basically saying whatever this value is this, right? So it's saying set this property name equal to this value, okay? So it's say, and then in here, since we're using these properties and our variables are private, right? This is how we set our private instance variable up here by underscore name, and then whatever value was passed in, okay? So that's what we're doing for name. And then the next, when we would call this constructor, then we have two more. We have two booleans, and it's saying if has Sunday, right? So if this is true, if you pass it a true for this, it's going to create a new Sunday object, okay? It's going to create a new Sunday object, right, from the Sunday class, right? The Sunday class is a blueprint, right? And the object, when we do this, we are instantiating, right? We are instantiating object from the Sunday blueprint class, right? And then has soda, If this is true, what we're going to do here is basically the same thing here. We have soda equals to new soda. And so this also causes, is a little confusing. Well, kind of does cause a lot of confusion here because this is just your type. If this type up here was this, let's just say, let's just change this. Let's just say something like that, right? I'm not going to leave it like that, but just so obviously here, this is your type and this is your name. So basically here, you would actually be doing it like this. My Sunday, right? Over here would be my soda, right? So this is your property you're using and you're creating a new Sunday so that this will now be the instantiated object up, right? Well, it'll take this and then it's going to do a set, and so it's going to set Sunday to this instantiated object. Now you've got this as object. Right here, by default, this is null. Strings are null by default, so are objects. This is null by default until you set something on there. So basically what you're doing here is you're setting a new Sunday on here, right? Same thing with soda, okay? But I'm going to go ahead and put these back just to make this understandable a little more, because I can understand that can be kind of confusing there. So we're going to put it back. Okay. And then we're just doing the get price here. Okay. So then I wanted to here's kind of a, whatever you called your different variables, that's kind of up to you. But, here's an order name, right? So that was that text box, the order name. The check box, so we have different check boxes, is Sunday, is soda, right? And then here was our different types of, so basically this is your checkbox name, and you're saying dot checked. If it's checked, then this is going to be true, right? For all these cases, if your check Sunday is checked, this is going to be true. This is going to be true. Depends on if you check it all the way through. So you got a bunch of Booleans here, right? It's basically all you have is a order name and a bunch of Booleans, right? If they've been checked, right? So like I first said, we come in here and you want to verify that you either have one or both Sunday and soda checked and an order name, right? So in this case, we're saying if it is a Sunday, and this is a string utility. And if you want to go ahead and, make a screenshot of what we're doing, if you're still working on getting this lab done, that's fine. Obviously there's different solutions to everything. So, maybe your solutions could be a little different, but if you want to make screenshots to help you out a little bit, feel free to do that. But this is a string utility method called is null or empty. And so this is basically asking if this is null or empty. So if it is null or empty, right? But you want to make sure it's not null or empty. I want to make sure this is not null or empty, meaning there's a value in order name, right? We want to make sure that order name has a value. So is Sunday is checked and this, or is soda checked and also we have an order name, right? And just to kind of review, remember when we do or, we're obviously later you can check both of them, right? But at the beginning, we just want to know, do we at least have the minimal data that we need to create an object, right? We have to make sure we have an order name, and we have to make sure that we either have a Sunday checkbox checked or a soda checkbox checked, right? And that's what we're doing here. So then if one of these are not checked, You know, you don't have the order, and one of them is Sunday or is soda's not checked, and we want to return to the screen. And that's where you probably, like I said, probably best just to have that label there and have it invisible, right? Visibility set to false, and then you can change the visibility of that label to true, right? Change it to true and return to the screen, right? And then if the next thing you probably want to do, if that succeeded, right? If that first part succeeded, then if it is a sundae, make sure there's only 2 toppings selected, right? If a soda, make sure that only 1 flavor is selected, okay? I'm not going to go through the code for that. You know, you can figure that out yourself. You know, we've done this, you know, for quite a while now, so I don't want to go through every single scenario. But basically, you know, make sure that you've got everything, because there's no reason if you select it more, there's no reason to create your order object until you know that you have what you need, plus you don't have more than what you need, because it's not valid, right? Because if you selected 3 toppings, that's not valid. So you want to make sure that everything's valid for you to create your order first. And then once it is, right? Let me just make this bigger, make things a little easier. Once it is, then you want to go ahead and create an order, right? And to create an order, we use the constructor, right? We use the constructor that's in the class. And we pass in the order name, right? And then we pass in, is sundae checked or is soda checked? Okay. So now we have a order object, right? And so now that we have an order object, we can start adding different things, right? So we've got these is sprinkles, is nuts. These were all the check boxes, right? Is sprinkles, is nuts, is chocolate syrup, right? So we can take our order, right? And then we can call sundae. And then we better go look at that one, because sundae, actually the sundae object. So when you call an order.sundae, let's go ahead and look at that again here. Because so when you call that sundae on that order, you just remember an order is now this order class, right? An object, right? So you're calling this object. So we need to go look at the order class, and we see .sundae. What is that calling, right? So back to this one. It is calling this, right? It's calling this. And the way that it's calling that is a get. Because, and I know maybe that's a little confusing. It's because you don't have an equal sign. You're not if you had an equal sign, order.sundae equals something, that's basically you're calling a set. But when you have it like this, you're actually calling the get method of sundae, right? So basically, you've already got, since you've created your new order here, right? So back to that real quick here. So in here, since you call that constructor, right now you've got this thing is populated. This has a value. Like I said before, this was null and this was null. When you called your constructor, right, you passed in your name. It's going to set your name to name. This is going to say, if this is true, create me a sundae object. If has soda is true, create me a soda object. And so if both of those were checked, right, when we created our new order, like what we just looked at, we called that constructor, we would now have this would now have a sundae object, and this would have a soda object, okay? And so then when we called this an order, which is an order, you know, this is the variable name we're given to the order. When we called that, right? When we called that, we are calling this we are calling this Sunday, and we're doing a get, right? Because it doesn't have an equal sign. Set, you're always going to see an equal sign. You're setting a value. You're calling a get. So basically, you're returning underscore Sunday. Well, underscore Sunday is basically a Sunday object, okay? So here it's returning the Sunday object, right? And the Sunday object has a method in it called add toppings. Add topping, okay? And I don't think I have all of these there. Let me go back to... I don't want to do that. Nope. Let me grab something. I need to grab something else here. Bear with me here for a sec. So here we've got there's an order object. Here's our Sunday object. And our Sunday object has this method called add topping. Okay, so that's what we're calling add topping, right? And then we're going to pass in a topping, right? And it has to be of this type, right? It's got to be of that enum, right? It has to be one of those types that's in there. And then once it's there, we go ahead and add that topping. We increment our topping count by 1. And here, and we're calculating our price each time, right? So it's going to calculate price each time. This is one way to do it. There's other ways, obviously, but it's just every time you add a topping, it's calculating the price, which, isn't really that relevant, but it is calling calculate price. Okay. But you're just adding the topping. Okay. All right, where were we here? So now we know that an order is a variable for order here. Sunday is actually our property name, right? So it's basically saying get Sunday and we have an order, get the Sunday, and add a topping. And the add topping is a method within Sunday, right? So it's saying if is sprinkles, add the topping, sprinkles. If it's nuts, add the topping, nuts. If it's chocolate syrup, right? So basically, if that checkbox is checked, add the topping chocolate syrup, right? And this is basically doing the same thing here for soda as well. You've got your order, right? And then inside an order also has that property soda. So this is saying get the soda. So from my order, get my soda, add flavor. So if it's lime, you do a soda flavor lime. Is peach, right? Add the flavor peach or mango, okay? And then if you, let's see, how did that have that? Did it show the topping count? Well, this is how you can get the topping count, right? So an order, here's your order, here's your property name, get Sunday. So basically an order gets the Sunday, and then there's a topping count, right? A topping count, also a topping count property there, right? So then you can get your topping count. So that will be how many toppings you have. So this is just for displaying, it depends on how you want to implement this. This is for displaying the Sunday, and this is for displaying the soda. So just to go through some enums again. So, some of the reasons to use enums. Let me go through this document here a little bit. Just a little bit. An enum is short for enumeration. And in C#, it's a special value type that allows you to define a set of named constants. Okay. Enums are typically used when you have a collection of related values that represent distinct entities or states. Enums improve code readability and maintainability by giving meaningful names to numeric values. They're very helpful. We're using some simple little things, but this is if you've got a big application, it'd be best, in some circumstances, because you can control. You don't want people just freelancing, calling things different names. And a lot of times, if it's a certain set of things like days of the week, well, you don't. People might just use abbreviation, SUN for sun, right? MON for Monday, and so it's probably. It's best to kind of use these where you can, where it kind of makes sense that these are the specific names, and then you make sure that they do match, so that people just don't do whatever. But like I said, the reasons for enums, it improves readability. Enums give meaningful names to values, making the code easier to understand. For example, instead of using a zero because basically, yeah, some people do this too, because they'll Sunday is a 0, Monday is a 1, right? So instead of using 0 to represent Sunday, you can use days of the week, right? Just a different way of doing things instead of trying to get things out of a list or something like that, right? Better type safety. Enums limit the possible values that a variable can take to be to the predefined constants within the enum. This helps avoid invalid or arbitrary values. That was I was kind of saying. People might, instead of doing Sunday, they might use SUN or whatever. So it kind of makes it better type safety. Easier to maintain, that you could have a list of different enums for different things that are important for your application. Less error prone. If people enter the wrong data, if somebody's can enter the wrong data, or a programmer writes something wrong, at least that kind of prevents them. If they're using the enums, it prevents them from doing, something incorrect. They have to follow those enums, right? So, let me just some quick reasons to use them. So let's look at. So we've seen days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday. We're aware with that, but so then here's error codes, and so this is kind of different. So basically, and this is very popular within programming too, is because you have different. A success can be, well, that's not really a success is usually a 202, but whatever. I'm just going to leave it. So these are like what's called HTTP responses. So let's just say you go to a web page that doesn't exist anymore. In programming, the servers, because these servers have to follow certain rules. And so what they'll actually return back to the browser, because they have to follow rules so browsers understand, what different things mean. So basically, a 404 error is a not found error, right? And so that's basically what a server will return. If a page is not found, you call a certain website and it doesn't exist, it's going to return a 404 error, right? An internal server error, this is some problem within the server, programming error within the server. And this is a bad request. You didn't send the right amount of parameters, right? Now, you don't necessarily always, end user, as you or I were just browsing the internet. But from a programming standpoint, yeah, these things are very important. But here, with these enums, you can, you can set the success equal to 0. And I'll show you that here in a minute. Book. This is just showing. Okay, that's doing a 2 string. So here, yeah. So here I'm running. So and actually here I just wanted to kind of refute. So actually you can get, even though you're just seeing Sunday, Monday, Tuesday, Wednesday, by default these are all ints. This is a 0. This is a 1. This is a 2. This is a 3. This is a 4, etc. right? And to actually get, if you know, there's reason for that, if there's a reason for that. So here it's just showing an example, like what we've been used to so far. Days of the week, Friday, it's just going to, you know, it's going to find Friday in there, right? In this case, you're doing Wednesday, and you're saying, let's convert this to an int, right? So this is going to actually return, let's look at this, 0, 1, 2, 3. Just letting you know that this is possible, and just so you're aware. So this will return 3. Let's just run that. Hopefully this will compile and work. Okay. So yeah, numeric value of Wednesday is a 3. Here, and then here there's an error code. That was where the 404 errors and stuff like that. So let's just say basically you get an error that's not found. Well, what does that mean? So you can have an enum basically, right? That you get an error cut. Well, you know, or you can do it the opposite way too, right? You get a return a 404. Well, what is that? It's not found, or you know, the other way, right? So let's just say I want to return a 404 error, right? And so you do some logic, and the page is not found. Then you're going to say, then you can use this, using it this way, not found, it will return a 404, right? So you can actually, one thing can refer to a value, right? So here it's doing that, but basically, yeah. Let's just get rid of this. If I do this, so now found will just return a 404 right here. Okay. Just some different options here with enums. Okay. Let's go ahead and I know we haven't gone. We're almost getting close to an hour. Let's go ahead and do a 15-minute break, and I'm going to go ahead and come back and go through. We're going to go through. I'm going to lecture over 15 a little bit. I don't want to. I don't want to. You know, just talk, and you know. So I'm going to go through a few different concepts. We're going to go through a little bit of the interfaces and generics. I'll try not to go through too much, and I'll go ahead and where we need to know certain things for the labs. When I create the separate video for that, I'll go through the different topics that's needed to get through these. Okay. And I'll also take another look at the written test for 15 as well, and make sure that study guide, or I'll send something out separately to make sure that all those concepts are covered. So yeah, let's go and take a 15-minute break, and then we'll go ahead and do that lecture on 15. So the first thing I wanted to go do is kind of just a quick discussion. This is something we actually covered yesterday about abstract class, but there's a little bit of overlap conceptually between abstract classes and interfaces. So an abstract class is a class where you basically create a methods, and you create a class that the whole purpose of that class is to be subclassed by another class, right? So in some cases, that's not the case. Maybe you have a class that does not, maybe a product class that doesn't need to be that can kind of exist on its own. But other times that's not always the case. So let's just look at an example. Let's say an animal class. So an animal class probably pretty much by itself may not really do anything. You have to have what kind of animal, right? So you have a dog or a cat or a bird. Well, now you've got now you've got a real animal to speak of, So the animal class could be an abstract class, and then the bird and the cat and the dog can actually subclass that. That's the animal's the base class. You can actually extend that class for your own purposes, right? And that kind of makes sense in that kind of situation, right? So the important thing to understand is abstract class cannot be instantiated, right? It's not going to have a constructor. You can't create a object of a abstract class. The whole purpose of an abstract class is for it to be subclassed by other classes, right? To declare an abstract class, you include the abstract keyword in the class declaration, right? Now you can have abstract methods and properties in there, and you also mark those as abstract as well. But you can actually have fully functional methods as well, right? Sometimes you might not, if you mark it as abstract, that means basically you're not providing implementation. The classes that subclass that, they decide on the implementation of that method, right? But you may have methods in there that's not stated as abstract, and they could be regular methods, okay? And they are the way they are going to be accessed is basically they are accessed by the classes that subclass that, right? That use that base class. So in the case of an animal, we have a method called speak for an animal. I think we looked at that, where animal speaks. Well, you can override that method, but you can also use that animal speak method. And even if it's an abstract class, you can use that method, right? You just cannot create an instance of an abstract class. Okay. So what are interfaces? So in some object-oriented programming language, such as C++, Perl, a class can inherit more than one class, right? But other languages, such as C# and Java, there's no such thing as multiple inheritance. There only can be one base class. Once you inherit from that, once you state it that's your base class, you inherit it from that. You can't inherit from multiple ones, only one, right? So the fact of multiple inheritance, and like it says here, C++ and Perl, when you can inherit more than one, that's called multiple inheritance, right? An interface provides many of the advantages of multiple inheritance, because what you can do is you can actually bring in multiple interfaces into your class. You only can use one base class, right? You only can inherit from one other class, but you can implement multiple interfaces. Okay, you can implement multiple interfaces into your code. So in some ways, an interface is similar to an abstract class. That's why I kind of showed you that abstract class again, right? Abstract classes and interfaces can both include one or more members that aren't implemented, right? So like we talked about, you can have from an abstract class, you have maybe one that you have the full implementation of that method. The other one you might signify that that's an abstract method, and you don't provide the implementation. That has to be provided in whatever class inherits that, right? Just to let you know, especially if you're ever looking at older code, prior to C# 8.0 version, an interface couldn't include the implementation of any of its members, like abstract classes could. So like I said, an abstract class, you can have both abstract methods or you can have non-abstract methods, right? And they're both inherited by the child classes, right? but in an interface, and like interfaces are similar to classes, right? But you used to interface, you could never have a method that provides any what we call the concrete implementation. You wouldn't create a complete method in an abstract in an interface class, right? In an interface class, you wouldn't create a full method. You would just create a just a it's basically a no implementation. You just declare the name of it and you have a semicolon and that's it, right? And then any interface, and then any class that implements that interface, right? Any class that implements the interface would have provide their own implementation of that method, right? Another thing, the relationship you can look at. So a lot of this when we start talking about object-oriented programming is relationships. Like we seen in the UML, there's one to one, one to many. It really just boils down to a lot of like relationships. And with inheritance, right? It's the relationship between a parent class and a child class, or you can call it a base class and a subclass, right? We said that both a child class and a subclass is basically the same thing, right? So a lot of this is about relationships, right? And so that base, that child class, or it's a derived class is the other one. So, a derived class, a child class, and a subclass are all the same thing. It's basically, it just depends on your view and how you want to look at it. But basically, let's just call it a child class. So a child class inherits from a base class, inherits from the parent, right? Like I said, in object-oriented programming, and when you're talking about that, basically, it's all kind of really about relationships, right? So then, with an interface, what's the relationship with an interface when a class decides to implement an interface, right? It's kind of a contract. It's a contract between the interface and the class. It's okay. You can look at it as a contract, okay, and that's kind of what's kind of used in the industry is to understand that is whenever you implement interface, any of those methods that didn't provide a concrete implementation, right? Didn't create that complete method. You have to create that, right? You have to create concrete implementations for all that methods, right? That's just how that kind of works, and it's very useful for programming certain types of relationships. Okay, let's see here. An important difference between abstract. Let's see here. So here's a interface called. Whenever you create an interface, always start with an uppercase I, right? Always start with an uppercase I. So that signifies. So if somewhere in your code you end up seeing, when you implement that interface, you see that uppercase I, that's an interface. Always start with an uppercase I. And then for an interface, it's not a class, it's an interface. So you use the word interface, right? It's still a C# file, but it's of type interface as opposed to a type class or type enum, right? So a product class implements an iDisplayable interface. So this is a product class and you're implementing a interface. This is how you do it, pretty much the same ways you would do a class, right? A base class. But in this case, it's an interface. And that's another good reason to make sure you always start it with an uppercase uppercase I, is so that you can obviously tell that, hey, yes. And actually, an uppercase I and also the next character also being uppercase. You really want to be able to make sure that you can say, oh yeah, just by glancing at it, oh yeah, this is implementing an interface as opposed to inheriting a base class, right? Because you do the same thing for a class, right? You put the base class here, but in this case, you're doing an interface, right? So, and this is showing you've got this get display text, right? This is the method that's defined there in the interface, but this is just a declared method, right? You're not providing you're not implementing this method. You're not, creating the full method, so to speak, right? You're not implementing the method. But so anytime, like I said, whenever you implement an interface within your code, this is a class that implements this interface, you have to provide a concrete method. You have to create a concrete method of whatever's defined in your interface. All right. So in this case, you got get display text, and if you come down here, you're providing a concrete implementation of get display text here. Right? If you don't do this, you'll get an error. You'll get an error. The editor will complain to you, or if you tried to actually compile it, because sometimes you don't always use things from a WinForms app. For this case, class, we're using WinForms apps a lot. But if you're doing things differently, you might be writing some kind of a service that's really outside of the WinForms app. If you're implementing an interface, it won't compile, right? If you're, what I'm saying, if you're implementing an interface where you didn't provide a concrete implementation of the method, then it will not compile. Okay. A comparison of interfaces and abstract classes. Both interfaces and abstract classes can provide signatures for properties and methods that a class must implement. Okay. So that's the same thing there. So like if you defined a class as abstract, right, you have to provide a concrete implementation of those methods as well, all those abstract ones, right? But if you didn't mark it as abstract, right, in a abstract class, if you didn't mark it as abstract, a method, then you don't have to provide a concrete implementation. But when you do that, you're already providing that concrete implementation within that abstract class. So both interface and abstract can implement some or all of their properties and methods. So which, like we just stated earlier, prior to C# 8th version, version 8, interfaces could only provide the declaration. They couldn't provide the concrete implementation, but now both abstract classes and interfaces can both provide a concrete implementation of methods, or they can just declare them, right? And if they just declare them without providing that, then the subclasses, in a case of a abstract class, it's inherited, right? So the subclass has to provide it. In respect to an interface, whatever class implements the interface, it must provide a concrete implementation of the methods, right? An abstract class can use instance variables and constants as well as static variables and constants, right? So just to kind of review about the whole idea of static. Remember that static means that you don't have to create an object to, like, let's say you have a static variable, and that's their static variables. Let's say a product price, a price of a product, and it's $10, and it's and that's your static variable, that all books are $10, right? So to access that static variable, all you need to do is the name of your class, dot, and the name of the variable, and you can access that without creating a object, without creating a instance of that class, right? Without creating an object, you can access directly, right? That's static. And just to kind of review a little bit, that's why remember I've said before that's why the main method is static, because there has to be an entry point into that class, and to get into that class you have to have a static method, right? Okay, a class can inherit only one class. We discussed that, including abstract classes, right? You only can inherit one class. but a class can implement more than one interface. You can implement multiple interfaces. An interface consists of a set of signatures for one or more methods, properties, indexers, or events. We kind of already talked about C# 8.0 or later. To implement interface, a class must name the interface on the class declaration. To implement interface, yes. Yep, and it must provide an implementation for every non-default member of the interface. All right. So now you can obviously, you can create your own interfaces, just like we're creating our own classes in our labs now. But also .NET has a bunch of interfaces as well, right? And here's some of their interfaces, and we'll discuss what these mean later. But iClonable, iComparable, iConvertible, iDisposable. So there's a ton of different interfaces that .NET provides that you can actually implement for certain needs that you may have. Okay. Like clonable returns a copy of the object. Sometimes you may want to return a copy of the object. You want to save a copy of the object, and you might make some changes to that object, and then maybe something happens. That's a good use case for that. So let's say you have an object, you clone that object, and let's say there's a lot of logic involved in it's a very complex object, and you're updating that object. You may get to a point where something happens, and then for some reason, the user clicks cancel or whatever, and then what you would do is basically the object that you're modifying, you can basically just go ahead and get rid of that, and you have a clone of that object, right? Or you can use that sometimes. Another good reason to use that is you might have an object that has a bunch of different variables, and you want to a very complex object, and then you just want to compare. Say, what's different between these two objects? I only want to know what's different between the original object and now this newer object that's been updated, right? So here's some commonly used .NET interfaces. iClonable creates a duplicate copy of the object. iComparable compares objects. Okay. And what you can do is like this. You talk about these interfaces. How you need to, you have to create a concrete implementation, right, of an interface. And this is a good one here because you're doing like this compare to, right? This iComparable interface has this method called compare to, right? And so it's taken one object and comparing it to another object, okay? You're comparing one object to another object. And so, we already seen, and we've already talked about before, when you compare two objects just by default, like doing equals on two objects, it's basically just going to, if it's a distinct object, like you create object one and then you create object two, there's no difference between those objects, but just because they are distinct objects and they're stored in a different, right? They're in a different memory location. They're not equal to each other, right? You get a hash code. We looked at yesterday getting hash codes on objects. So when you get a hash code on that object, right? When you get a hash code on the object, the hash codes are going to be different. They're not the same object, right? They're distinct objects, right? So a good use of this iComparable is basically you overwrite this compare to object, and you do that. Let's say you have an object that has a name, an address, a zip code, all of these things, right? So, and let's say that you've got two objects that have the exact same name, zip code, an address, street address, and they're exactly the same, right? Now, if you just do you just do an equals on that. Obviously, we already said that if you have two distinct objects, even if they're the same, right? They're not going to be equal. Well, but sometimes you want to know if two objects have basically the contents of them are equal, right? Are the contents of them two different objects equal? So you can use this compare to, and then you would override compare to look at those different fields that you have, right? Being name, address, zip code, and that's a good use of this iComparable, right? iConvertible converts an object to one of the common language runtime types. Yeah, I don't think a lot of this. I don't want to get into anything that's just going to be confusing. And we're not going to be using it anyhow. Yeah. Well, a lot of your collection stuff, commonly used interfaces for collection, a lot of the collection stuff are interface based. So we will look at that a little more, right? We've already used list, right? So yeah, we'll look at those a little more. Not now, but later. So .NET defines many interfaces that you can implement in your classes. However, many of these interfaces have been updated by the generic interfaces that are presented later in this chapter. I'm not going to go through all that. All right. So how to create an interface. Okay. What page are we at here? Let's go over this one. So syntax for creating an interface. Okay. So basically, like what we've seen earlier, here your access is public, and you need to use this keyword interface to define an interface, right? And you get an interface name. You always want to start with an uppercase I on it, right? You want to make it obvious, especially because when you subclass not subclass it, but when you in a class that implements an interface, right? In a class that implements an interface, you want to be able to tell that, hey, yes, I'm implementing interface as opposed to inheriting another class, right? Okay. Yeah, this is just nothing special here. So here's an interface that defines one method. All right. And we kind of already looked at that. So this is whatever interface implements this, you're going to have to overwrite this, right? An interface that defines two methods and a property. So same thing here. So same thing here. You're going to have to, if you implement this interface, you're going to have to provide a concrete implementation of a read and save object, right? A read and save method. The syntax for creating interface and inherits other interfaces, okay? So yeah, we already talked about how a class can implement an interface, right? It can implement multiple interfaces, right? A class can implement one interface or multiple interfaces, right? And we always talk about a class, right? A class can inherit another class. A class does not inherit an interface, right? It inherits another class. Now, an interface can inherit another interface. Interfaces can inherit other interfaces, right? But a class does not inherit an interface. A class only can inherit another class, right? So here's the syntax for an interface that inherits other interfaces, all right? And so, yep. So here's a example of interface that inherits two interfaces. You just put a comma in between, right? So the declaration for interface is similar to the declaration for a class. The only difference is that you use an interface keyword instead of a class keyword. The non-default methods and properties that are declared within an interface can't include implementation, okay? As a result, non-default method declarations and non-default get and set accessors always end with a semicolon. Okay? Let's kind of go back and look at that. Yep. It ends with a semicolon. Ends with a semicolon. All right? With C# earlier, all members of interface were considered to be public and abstract. And static members, okay. You include any access modifier in an interface, okay. Yeah. Okay, how to implement interface. Interface, let's see, where are we at here? Hold on. So when you enter a name of an interface on a class declaration, you can automatically generate stubs for each member of the interface. So yeah, that's very helpful that you can automatically. So like when you automatically, let's see, when you enter a name of interface on a class declaration, you can automatically enter for the members of the interface. Yeah, because there's there's certain things like we talked about that you have to override. So basically, in your code, using the editor, it's a feature of the editors. It'll give you that, it has that functionality that'll actually include those. It'll include those methods in your code that you need to provide that concrete implementation for. Right? And to do that, you can click in the line that contains the name of the interface. So a light bulb appears in the margin. Then you can click on that light bulb to display a quick action menu that contains the two commands. All right. If you select the implement interface command, code that's similar to the code in the second to the last example. Okay. So that's something we'll look at. I'll review that. I'll review that concept when we go through when I go through the chapter 14 and 15 labs, because there's a few different concepts I want to go through, and I'll go ahead and go through doing that as well. So that's basically showing the syntax for implementing an interface, where you got this class product, and then you're implementing this clonable, right? And this just shows you how to do two interfaces. And here's a quick action menu for the interface name, where you can click implement interface, right? And it'll basically, the code that's generated when you implement the interface. So yeah, so like in this clonable, there's a public method called clone. And it will go ahead and generate that, and then you make changes as needed. To declare a class that implements one or more interfaces, type a colon after the class name, then list the interfaces out. Okay, which we know that, right? Colon. Pretty basic there. So here you see here's a example of a product class that implements two interfaces, iDisplayable and iClonable, right? And the if you recall in iDisplayable, it had this method here. It had that method there. And so you have to provide a concrete implementation of that one, right? And then the other one you have to create is the iClonable. And like if you like it showed, you can use the IDE, the Visual Studio IDE, that'll automatically stub it out. And what stub it out means is just going to create the basic method name in that. This is what you as a programmer would have to provide, right? You would have to provide this code, right? This is your concrete implementation of this clone method, right? All right. Yeah, I don't want to spend too much time on this, but just so here's a method create list that actually uses interface as a parameter. So you can actually use this as a parameter, and here you got the OBJ for object. You're actually calling clone, right? You're calling that clone method on that, right? And then obviously, within your you're still gonna have to overwrite that. You have to have that overwritten clone thing, but you're passing in this clone object into here, okay, or this interface. Okay. I think so. I think I'm going to go ahead and I'm not going to cover any more of this today, but I am going to make sure that there's some parts of this chapter that's needed for the labs, and also I'll make sure that I cover some of the things that will be in the written test as well. So I'm going to go through that. So I'll go ahead and create another video that's going to be the labs, and it'll include some of this chapter as well. So so that's all I have for today. Has anybody got any questions about anything? And I guess one of the things is, anybody have any questions about the hands-on test? Are you good with the hands-on test? I guess is the most important thing right now. So